Welcome to the Deep Dive. Today, you get a front row seat to, well, sort of a mock senior Java developer interview.
That's right.
We're going to really get into three absolutely crucial object class methods: toString, equals, and hashCode.
Yep, the fundamentals.
Think of this as more than just interview prep, though. It's really about understanding the bedrock for writing solid, reliable Java code. We'll cover practical stuff, pitfalls, best practices.
Let's jump in. All right, imagine I'm the interviewer. You, listening, you're hearing the kind of questions a senior candidate really needs to nail. First one up. Can you explain the purpose of the toString method in Java?
Classic. And for good reason. So yeah, bottom line, what's toString all about?
Basically, toString is there to give you a string representation of an object. It's how you get a text description of what that object is, or at least what it holds.
Okay, simple enough. But what happens if you just don't touch it? What's the default behavior we get?
Well, the default method, the one you inherit straight from object, it gives you the class name followed by an @ sign and then the object's hash code, usually in hex.
Right.
So, for example, if you just printed system.out, like system.out.println open parenthesis system.out close parenthesis, you might see something like, I don't know, java.io.printstream at 2f6684.
Yeah, that doesn't exactly tell you much about the object itself, does it? It looks more like it's cosmic address.
Exactly. It's not a useful description, and that's why overriding toString is, well, pretty much essential if you want something meaningful.
To get useful info about the object's actual state?
Precisely. You override it to give a string that reflects the object's state. A really common format is, the class name, then maybe square brackets with the key instance variables and their values inside.
Okay, let's make that concrete. Say we have an employee class. It's got name, it's got salary. What would a good toString look like there?
Yeah. Okay, yeah. For an employee with name and salary, a solid toString would be something like this. Public string toString, open parenthesis, close parenthesis, open curly brace, return getClass, open parenthesis, dot get, name open parenthesis, close parenthesis, plus, open bracket name equals plus name, plus comma salary equals plus salary, plus close bracket, semicolon, close curly brace.
Nice. And I noticed you used getClass, open parenthesis, close parenthesis, dot get name, open parenthesis, close parenthesis there. Not just typing employee. Why is that better?
Good catch. Using getClass, open parenthesis, close parenthesis, dot get name, open parenthesis, close parenthesis is smarter because, well, what if you have subclasses?
Right, inheritance.
Yeah. If you subclass employee, say you make a manager class, this way the toString method automatically picks up the correct class name, manager, without you needing to change anything in the employee's toString or override it just for the name. It's just more robust.
Makes sense. Handles inheritance nicely. Okay, so speaking of subclasses, let's take that manager example. It extends employee, adds maybe a bonus field. How would its toString build on the parents?
Good question. So in the manager class, you'd want to reuse the employee's toString output. You do that using
super.toString.
Exactly. Super.toString, open parentheses, close parentheses. You call that first, and then you just append the manager specific stuff. So it might look like public class manager extends employee, open curly brace, ellipsis, public string toString, open parenthesis, close parenthesis, open curly brace, returns super.toString, open parenthesis, close parenthesis, plus open bracket bonus equals plus bonus, plus close bracket semicolon, close curly brace, close
Clean. Reuses the base implementation, adds the extra bit. Love it. Now, sometimes this toString thing just happens, right, without us calling .toString explicitly.
Oh, yeah, the compiler helps out here. Whenever you concatenate an object with a string using the plus operator.
Like details. Tuss my object.
Precisely. The compiler automatically inserts a call to my object dot to string open parenthesis, close parenthesis for you. So if you had, say, var pose equals new point open parenthesis 10, comma 20, close parenthesis, semicolon, string message equals empty quotes. The current position is empty quotes plus post semicolon. That pause automatically gets its toString called.
Handy. The compiler just figures it out. And isn't there a shorthand for that too? Like if you just want the string version quickly.
Yep. You're probably thinking of the empty quotes plus X trick.
That's the one.
Yeah, just doing empty quotes plus X is often a concise way to get the string representation. And what's neat is it even works if X is null, gives you this string null, and it works for primitive types too. Java handles the conversion.
Good little shortcut. Now, any gotchas, any places where toString behaves unexpectedly?
Definitely arrays. Arrays are a big one.
Yeah.
They inherit the default toString from object, which, as we said, isn't helpful.
Right, the class name and hashCode thing.
Exactly. So if you have, like, An array of primes. Int-array primes equals open curly brace 2, 3, 5, 7, 11, 13, close curly brace semicolon, and you try to print it using primes.toString open parenthesis, close parenthesis. You'll get something weird like I at 1A46E30.
Useless. Not the numbers you wanted. So how do we print the contents of an array properly?
You need the arrays helper class. For a simple array like primes, you use arrays.toString open parenthesis, primes close parenthesis. That'll give you the nice output. 2, 3, 5, 7, 11, 13.
Arrays.toString. Got it.
And if you have arrays inside arrays, like a 2D array, you'd use arrays.deep-to-string.
Okay, good distinction. So wrapping up toString, what's the key interview tip for our senior level listeners?
Simple. Always consider overriding toString. Make it a conscious choice. A good toString makes debugging and logging so much easier. It shows you care about how your objects are represented. It's just good practice.
Solid advice. Okay, let's shift gears to the next big one. Equals. Interviewer hat back on. What is the purpose of the equals method, and when should we override it?
Right. So the equals method fundamentally is about testing if one object is, well, equal to another object, but the key is what equal means.
Okay.
The default version, the one from object, checks for reference equality. It only returns true if the two variables you're comparing point to the exact same object in memory.
So the default is literally asking, are these the same physical object on the heap?
Exactly, which is often not what you want. Think about strings. If I have a string s1 equals hello and string s2 new string hello, they might be different objects in memory.
But we'd still want them to be considered equal,
Yeah.
right? Because they contain the same characters.
Precisely. And that's why you override equals. You override it when you need to define a quality based on the object's state or content, not its memory address. We call this state-based equality. The string class is the perfect example. It overrides equals to compare the actual character sequences.
So default equals is like asking, is this the exact same library book?
Yeah.
While overriding it lets you ask, do these two books have the same title and author?
That's a great analogy, actually. Perfect. Yeah. Now, here's the absolute golden rule, the non-negotiable part. If you override equals, you must also override hash code.
Ah, there it is, the contract.
The contract. They are inextricably linked. We'll get into why with hash code in a moment, but just burn that into your brain. Override equals, you override hash code, period.
Got it. Package deal. So let's talk implementation. How do we write a good, robust equals method? Let's use an item class. Maybe it has a description string and a price double.
Yeah, sounds good. A typical solid equals implementation for that item class would look something like this. Pay attention to the steps. Public Boolean equals open parenthesis, object, other object, close parenthesis, open curly brace. First, if open parenthesis, this equals other object, close parenthesis, return true semicolon. Then if open parenthesis, other object equals null, close parenthesis, return false semicolon. Next, if open parenthesis getClass open parenthesis close parenthesis not equals other object.getClass open parenthesis close parenthesis return false semicolon, then cast var other equals open parenthesis item close parenthesis other object semicolon, and finally compare fields. Return objects dot equals open parenthesis description, comma other dot description close parenthesis ampersand price equals other dot price semicolon close curly brace.
Okay, well, let's break that down. That first if, this equals other object, what's that for?
That's just a quick optimization. If both variables are already pointing to the very same object, well, they're obviously equal, right? So we can return true immediately and skip all the other checks. Saves a bit of work in a common case.
Makes sense. Cheap check first, and the second one checking for null.
That's part of the equals contract. An object can never, ever be equal to null. So x.equals null must always return false. That check ensures we follow the rule.
Right, contract requirement. Then the get class.
Yeah.
If open parenthesis get class, open parenthesis close parenthesis not equals other, object.getClass open parenthesis close parenthesis return false semicolon. Why compare classes like that?
This ensures we're only comparing objects of the exact same type. An item can only be equal to another item, not, say, an order or something completely different, even if they coincidentally had similar field names.
Now, some people use instance of here instead of getClass. What's the difference, and why might getClass be preferred?
The great getClass versus instance of debate. So instance of checks if other object is an instance of item or any subclass of item.
Seems more flexible.
It can seem that way, but it often breaks one of the key requirements of the equals contract.
Symmetry.
Symmetry, meaning if A dot equals B is true, B equals A must also be true. Exactly. Imagine our item class, and we create a subclass called discounted item that adds a discount field. If item.equals uses instance of item and only compares description and price, it might say an item is equal to a discounted item if those match.
Okay.
But if discounted item.equals also checks the discount field, as it should, then discounted item.equals item would be false because the item doesn't even have a discount to compare. So item.equals discounted item is true, but discounted item.equals item is false. Symmetry broken.
Tricky. So getter class prevents that by insisting they must be the exact same class.
Correct. It enforces symmetry when dealing with subclasses that add state relevant to equality.
You mentioned sometimes instanceof is okay.
Yes, there's a specific case. If the notion of equality for a class hierarchy is completely defined in the superclass and subclasses cannot change that definition, then you can use instanceof and make the equals method final.
Like if employee equality was only based on an immutable ID.
Exactly. If the IDS is the only thing that matters for equality forever for all subclasses, you could do this in employee. Public final boolean equals open parenthesis. Object other. Object close parenthesis, open curly brace. If open parenthesis this equals other object close parenthesis return true semicolon, then maybe use the pattern matching version. If open parenthesis other object instance of employee other close parenthesis return id equals other dot id semicolon. And finally, return false semicolon close curly brace. Making it final prevents subclasses from messing with the symmetry.
Okay, that clarifies the instanceof exception. Back to our item example. After the getClass check, we have the cast. Or other equals open parenthesis, item close parenthesis, other object semicolon, straightforward.
Yep, now we know it's safe to cast.
Then the field comparison. You used objects dot equals open parenthesis description, comma, other dot description, close parenthesis for the string.
Right.
Why that specific helper?
Objects.equals is great because it's null safe. If description happened to be null in one or both objects, calling description.equals directly would throw a null pointer exception. Objects.equals handles null gracefully for you.
Very handy. Avoids NPEs. And for the price, the double, you just use price equals other dot price semicolon.
Right, for primitive types like double is usually fine for checking equality, though if you were super concerned about the nuances of nan, not a number, or positive negative infinity, you could use double.equals instead, which handles those edge cases specifically, but often is sufficient for typical business logic.
Good to know the option exists. What if our item had, say, an array field? Like a list of tags as a string. How would we compare that in equals?
Right. You wouldn't use equals or the array's own equals method because those only check reference equality for arrays. You need to compare the contents element by element. The way to do that is with arrays.equals. You'd pass both arrays to arrays.equals, and it would return true only if they have the same length and all corresponding elements are equal.
So objects.equals for objects, or maybe double.equals, etc. for primitives, and arrays.equals for arrays. Got it.
You got it.
And how would our discounted item subclass implement equals, assuming we're using the getClass approach?
Good question. The first thing discounted item.equals should do is call the superclass as equals. If open parenthesis, not super dot equals open parenthesis, other object close parenthesis return false semicolon.
Check if the item parts are equal first.
Exactly. If the basic item parts aren't equal, then the discounted items can't be equal, so we return false. If super.equals returns true, then we compare the field specific to discounted item, so cast it. Var other equals open parenthesis discounted item, close parenthesis other object semicolon, and then compare the discount. Return discount equals other dot discount semicolon.
Makes total sense. Delegate up first, then handle your own state. Okay, wrapping up equals, key interview tips.
Know why you override equals state-based equality. Understand the absolute necessity of overriding hash code consistently. Be ready to discuss getClass versus instanceof and the symmetry implications. And crucially, be able to walk through implementing equals step by step. The identity check, the null check, the type check, the cast, and the field comparisons using the right tools like objects.equals and arrays.equals.
Excellent. That brings us logically to the third pillar, hashCode. Interviewer asks, what is the hashCode method? And what is its relationship with the equals method?
Okay, so hashCode returns an integer. It's a hash code derived from the object. Its main job is to help hash-based collections like hashmap and hashset work efficiently.
How does it help them?
Think of the hash code as like an object's fingerprint. It's a number that helps these collections quickly group or categorize objects into different buckets. When you want to add an object or check if it's already there, the collection first looks at the hash code to figure out which bucket to even look inside. This narrows down the search dramatically.
An object's fingerprint. I like that. Helps find things faster in big collections. How unique should these fingerprints be?
Ideally, unequal objects, according to equals, should have different hash codes. This spreads objects out across the buckets, which is what makes hash collections fast. If lots of unequal objects end up with the same hash code, a collision, performance degrades because the collection has to check more items within the same bucket using equals.
So different objects, different fingerprints is the goal for performance. Now, that relationship with equals, we touched on it, but what's the non-negotiable rule again?
The critical contract, the law of the land, is this. If two objects are equal according to the equals method, so if x dot equals open parenthesis, y close parenthesis is true, then their hash codes must be the same. X.hashCode open parenthesis close parenthesis must be equal to Y.hashCode open parenthesis close parenthesis.
Equal objects must have equal hash codes. What happens if you break that rule? If equal says true, but hash code gives different numbers.
Oh, disaster. Hash collections rely absolutely on this contract. If you put object X into a hash set, it calculates the hash code, finds the bucket, and puts it there. If you then try to check if an equal object Y, where X equals Y is true, is in the set, but Y has a different hash code.
It looks in the wrong bucket.
Exactly. It calculates Y's different hash code, looks in that bucket, doesn't find an object equal to Y, and incorrectly reports that Y is not in the set, even though an object equal to it, X, is in the set. Your collections basically stop working reliably. It leads to maddening bugs.
Yikes. Okay, rule understood. Equal objects, equal hash codes. What does the default hash code from object do?
The default hash code usually generates a code based on the object's internal memory address or something similar.
Yeah.
This is consistent with the default equals, which also checks memory address.
Right, same address, same default hash code.
But as soon as you override equals to check state, that consistency breaks. Two objects can have the same state, so equals returns true, but be at different memory addresses. The default hash code would then return different codes, violating the contract.
Which leads us back to, if you override equals for state comparison, you must override hash code based on that same state. How do we do that?
The best practice is to combine the hash codes of the fields that you used in your equals method. And thankfully, Java provides a really easy way to do this, Objects.hash.
Ah, the helper class again.
Yep. For our item class, where equals compared description and price, the hash code method would simply be public and hash code open parenthesis, close parenthesis, open curly brace return, objects.hash, open parenthesis description, comma price, close parenthesis, semicolon, close curly brace.
Wow, that's really concise. What's objects.hash doing there?
It takes a variable number of arguments, our fields. It calculates a hash code for each argument, handling null values safely for objects, and then combines these individual hash codes using a standard algorithm to produce a single final hash code for the item object. Super convenient, much less error-prone than trying to combine them manually.
Nice. Null safe, and handles the combining logic. What about array fields? If equals used, arrays.equals.
Similar idea. If your equals method compares an array field using arrays.equals, your hashcode method should first calculate a hash code for that array based on its contents, using arrays.hashCode open parenthesis array close parenthesis. Then you pass that resulting integer hash code along with your other fields into objects.hash.
Okay, so arrays.hash code for the array field, then feed that result into objects.hash with the other fields. Makes sense. Can we peek under the hood of strings hash code quickly? How does it generate those fingerprints?
Sure. The standard string hashcode implementation iterates through the characters. It looks roughly like this. Int hash equals 0 semicolon, then a loop. For open parenthesis, int a equals 0 semicolon, a less than length, open parenthesis, close parenthesis, semicolon, I plus close parenthesis. Inside the loop, hash equals 31 asterisk hash plus charat, open parenthesis, I close parenthesis, semicolon.
Multiplying by 31 and adding the character value.
Yeah, that formula, especially using the prime number 31, helps distribute the hash codes well, reducing the chance of different strings accidentally getting the same hash code, though collisions are still possible, just less likely.
Fascinating. Okay. Common mistakes with hash code. What do people mess up most often?
The number one mistake is simply forgetting to override hash code when they override equals. Number two is overriding both, but using different sets of fields in each method. If equals looks at fields A and B, hash code must also be based on fields A and B, and only A and B ideally.
Yeah.
Any mismatch breaks the contract.
Consistency is everything. If it matters for equality, it must matter for the hash code.
Exactly. So best practice. Use all the fields you compare in equals to compute the hash code. Use objects.hash. It's easy, null safe. Use arrays.hashCode for array fields before passing the result to objects.hash.
And the interview tip for hash code?
Understand the why its role in hash collections. Know the equals-hashCode contract inside out and the dire consequences of breaking it. Be able to implement hashcode correctly and consistently using Objects.hash and arrays.hashcode. Explain why that consistency matters for things like hash map and hash set.
Fantastic. This has been a really thorough deep dive into toString, equals, and hash code. Before we wrap, any final overarching best practices or words of wisdom for developers aiming for that senior mindset regarding these three methods?
Yeah, absolutely. First, always think about these methods when you create a new class. Don't just ignore them. Make a conscious decision. Do I need a custom toString for logging? Do I need state-based equality? Equals. If yes to equals, then hashcode is mandatory.
Right.
Second, ensure your equals method follows its own contract religiously. Reflexive, symmetric, transitive, consistent. And keep hammering that equals hashcode contract. They must be compatible. Third, really understand the getClass versus instance of choice in equals and its impact on subclasses. When in doubt, getClass is often safer to maintain symmetry unless you have that specific final equals scenario we discussed.
Lean towards getClass.
Generally, yeah. And finally, leverage the helper classes. Objects.equals, objects.hash, arrays.equals, arrays.hashcode. They make your code cleaner, safer, and less prone to common errors like null pointers or incorrect hashing logic. Mastering these simple methods is truly fundamental to writing robust Java.
Couldn't agree more. So to quickly recap, toString for a useful text snapshot, equals for defining logical equality, and hashcode for that efficient collection fingerprint, all governed by the critical equals-hashcode contract. They really are the unsung heroes.
Well said. Get these right, and a lot of other things fall into place more easily.
All right, that brings us to the end of this deep dive. But now we want to turn it over to you, our listeners. We've all been there fighting weird bugs. So our question for you is, what's a surprising bug you've encountered due to a missing or incorrect implementation of toString, equals, or hashcode in Java?
Yeah, share those war stories. We'd love to hear them.
Head down to the comments and let us know. And while you're there, tell us what other Java concepts or deep dives you'd like us to tackle next time. Thanks so much for tuning in.